Hello, this is the first video of the Preliminaries Series 2 on further sets, combinations and permutations. And this video considers problem solving with more than two sets. We've looked at problem solving with sets in the previous series. Now this work is extended to larger and more complex problems. We know the inclusion-exclusion principle for two sets states that the number of elements in A union B equals the number of elements in A plus the number in B minus the number in the intersection. So in this diagram, if we have that this set is B and that is A, the number in A union B in that area, this is A intersection B. So the number of elements in there are in both A and B. The number in A would be the number in this whole circle here, and the number in B would be that whole circle there. So if we were to add those two circles, we would have counted this middle portion twice. And that is why we have to then subtract it. So for example, in a standard deck of 52 playing cards with 4 suits, spades, diamonds, hearts and clubs, how many cards are spades or aces? Well, we know we've got 13 spades and 4 aces. However, one of those, one will be the ace of spades. So therefore, the number that are spades or aces, or A union B, would be equal to the number of spades plus the number of aces minus the one card, which is the ace of spades, which would be in both sets. Hence there would be 16 cards that are spades or aces. We can extend this inclusion-exclusion principle for 3 sets, as you can see in the formula given here. Note that we add and then subtract and then add again, and this is to make sure that we only end up with this total number and don't count anything twice or take away anything more than once. So in effect, this is extending the idea of calculating more than we need and then taking something away and extending it to 3 sets. Call them A, B, C. Note that this formula is given on page 13 of the OCR formula book. Looking at this example, how many integers between 1 and 300 are divisible by 3, 4 or 5? Then we can define set A as being the multiples of 3, and set B as being multiples of 4, and set C as being multiples of 5. So let's think, what would n of A be? In other words, how many numbers lie in set A? Or how many numbers between 1 and 300 are divisible by 3? Dividing 300 by 3 would give us 100. Similarly, the number of elements in B will be 300 divided by 4, or 75. And n of C would be 60. What about the intersections? So let's think about what the elements in A intersection B would be. So they've got to be multiples of 3 and also multiples of 4. If we divided then by 12, lowest common denominator of 3 and 4, then we would get the number 25. So in A intersection C, we're looking for the numbers divisible by 3 and 5 or by 15, and there are 20 of those. And for B intersection C, those divisible by 4 and 5 or by 20, and there are 15 of those. Finally, we want to see what numbers or how many numbers there are that are divisible by 3 and 4 and 5. So if we divided by 60, we would find there were 5 numbers. We can then use the above formula. And by substituting in those numbers, being careful when we add, and then when we subtract, and then add again, to get the final answer of 180. Let's just be clear about why those plus and minuses work. We know we want the numbers in that space there, all of A union B union C. We know these ones are the intersections, and when we take them away, then you can see that we will end up taking away this section more than once, and therefore we have to add it back in again at the end. Let's have a look at another example where we won't have to draw the Venn diagram necessarily, although we could. We can use the same inclusion-exclusion principle, because although we're told some of the information, we want to find out how many watch none of the 3 types of program. And therefore, it's easier to work out what people do watch and then take away that from the total. So let's work out the numbers we need to feed into the formula. If we have the A of a sport, so we'll make that the group A, and watching comedy is B, and watching drama is C, then N of A, we are told, is 110, so we know that one. N of B is 120, and N of C is 85. We are told that the intersection where we're watching drama and sport, so that's A, N, C, is 50. That the number of people who watch comedy and sport, so in other words A intersection with B, is 70. Number watching comedy and drama is 55. We're also told that N of A intersection B intersection C, or the people who watch all 3, is 30. So, if we put those numbers into the formula, we find that yes, 170. Therefore, to answer this question, we take that total, which we've given up here, 200. We take away the 170, and that will give us the fact that 30 people watch none of the 3 types of program. In the next video, we will look at permutations of subsets.